Hello good people, I'm going to talk about the good old days. How old? Well, some 4.5 billion years. The current scientific consensus is that around that time, the Sun, the Earth, and the other planets coalesced from a large and dense interstellar cloud. The cloud itself was much older. It was a remnant of earlier stars that lived and died in the afterglow of the Big Bang, somewhere between 5 and 13 billion years ago. In other words, our entire solar system stumbled out of a stellar graveyard. Do not wait for the zombie apocalypse. It already happened a long time ago. The Earth, back then, was a rather different place. It was a hot, molten mess characterized by a lot of volcanic activity and collisions with other solar bodies. One of these collisions was with a planet known as Theia. The impact was so huge that it nearly vaporized both planets. It ripped huge chunks of Earth's crust and mantle and flung them into the orbit. Over time, this debris coalesced to give rise to our Moon, also known as Luna. Not only does the Moon provide a romantic backdrop for all the other subsequent collisions in the night, but it played and continues to play a huge part in Earth's role as a garden world capable of giving and sustaining life. The moon-forming impact provided enough heat to vaporize a lot of locked-up carbon, giving rise to an atmosphere rich in carbon dioxide. Due to the heat, the atmosphere also contained a lot of water vapor. The volcanic emissions provided this ancient atmosphere with other molecules such as hydrogen gas, methane, ammonia, sulfur dioxide, and hydrogen sulfide. Note that this early atmosphere was devoid of oxygen gas. It was anoxic. As the Earth cooled, the water condensed and rained down to form the oceans. The rain also dissolved and washed down several of the atmospheric molecules, making them part of the oceans. The presence of the Moon stabilized the rotation of the Earth, and the tidal influence allowed for mixing of soils and oceans. So let's put all these things together. We have the atmosphere and the ocean churning with a lot of small molecules. We have high heat and UV radiation that can provide the energy for chemical reactions. We have exposed rock of early Earth containing metals that can catalyze chemical reactions. Something was bound to give. This prebiotic Earth was primed to do something amazing. It was about to give rise to organic molecules. Except for those of us with time machines, not many people were around back then. So how do we know how this all went down? The truth is that we do not know with 100% accuracy, but we can create some really good approximations that explain a lot of things. Stanley Miller, a doctoral student in 1952, under supervision of Harold Urey, performed an experiment that simulated a simplified version of the early Earth's atmospheric conditions. A glass vessel was filled with methane, ammonia, and hydrogen gas. Water vapor was introduced, and an electrode provided electrical sparks to simulate lightning. After the experiment was concluded, the collection flask contained several amino acids, the building blocks of proteins, one of the 4 main macromolecules of life. This experiment was relatively simple, and it isolated only a few amino acids. Subsequent, more refined experiments yielded more amino acids, sugars, lipids, and nucleosides, the building blocks of nucleic acids. In other words, all 4 macromolecules spontaneously emerge from conditions of the early Earth. Further experiments have shown how a protocell can self-assemble in the presence of macromolecules of life. The protocells are tiny membrane-bound vesicles that contain other biologically important molecules. These protocells are still a long way from a functioning living cell. At the time of this recording, nobody has been able to synthesize a living cell. Life is not an easy thing to crack. This is probably a good thing too. Nature, on the other hand, is the chief scientist, engineer, cook, and master sculptor. It would seem that in nature, life will spontaneously find a way. Note that research brings new ideas and evidence. What is actually life and how it all started is an ongoing discussion. What was presented here, believe it or not, is the simplest explanation based on the available data so far. Biology or any other science for that matter, is not static. As new evidence emerges, this story might change, or it might be reinforced further. That is all for now, and I will see you on the flip side.